Hello, I am Amit and we are learning artificial intelligence and machine learning. And we are going to discuss today module 6, that is advanced neural network concept. So first concept is back propagation and the optimization. What is back propagation? So propagation short for backward propagation of error is the learning algorithm used to train neural network. It's how a neural network learns from its mistake by adjusting the weight and the bias to reduce prediction error. Optimization equal to fixing the mistake. So step by step process. Forward pass. Input data flow through the network. Produce output. Then loss calculation. Compare output with the actual level using loss function. Example, mean square error and cross entropy. Backward pass. So back propagation. Compute gradient, partial derivative of loss with respect to weight. These gradients show how much each weight contributed to each error. Weight update optimization, adjust weight using the gradient descent or its gradient. The formula is W equal to W minus eta into dl and dw. Here W is the weight and eta is the learning rate and L is the loss. So gradient descent variant optimizer. Optimizer description and the key idea. So SGD stochastic gradient descent, that is description is update weight per sample faster and noisy. Simple but can be unstable. Momentum add velocity to update faster convergence, uh, RMS probe adjusting learning rate for each parameter help in non-stationary problem. Adam combine momentum plus RMS probe, most popular in practice. So Adam is the default optimizer in the most modern neural network, fast and stable. Visualizing backpropagation. So feature, meaning and the example. So 0.5 and 0.8 time spent on the website. Number of the page viewed normalized. So 50% of the average user time and 80% of maximum page. So neural network try to predict, will the customer make a purchase? Y equal to 1, yes, and y equal to 0 if no. So here is the new neurons used to feature browsing time and engagement to predict buying intent. So import NumPy as NP, simple neural network in neuron, one neuron only. So x equal to np.array 0.5 and 0.8, this value, that is input value, then y equal to 1, target output. So initialize weight and bias, w equal to np dot array 0.2 and 0.4, b equal to 0.1, lr equal to 0.1, diff sigmoid, return 1 by 1 plus np dot x minus x, diff sigmoid derivative, return x into 1 minus x. So forward pass z equal to np dot xw dot plus b, a equal to sigmoid, compute loss MSE, and loss equal to y minus a into 2, print f before training loss, back propagation dld equal to minus 2y, sigmoid derivative, gradient of loss with respect to weight, and update weight w minus equal to lr into grade w and b minus lr into grade. So print after one update, new weight is w bias b. Let's try to run this code. Okay. Before training, loss is 0.139. After update, one update, new weight is uh, 0.287185 and bias is 0.1437. So this way the model can train. So this demonstrates how each weight is pushed in the direction that reduce loss. Before training, loss is 0.139. Loss measure how far the neuron prediction is from the correct answer y equal to 1 in the your code. Higher loss means a bigger error. So initially your neurons output was somewhat wrong. It predict a value different from 1. After one update, new weight is 0.28 20871,853 and 041394965 and bias is 0.11743706444 like this. So these are the update parameter after one learning back propagation step. So here loss will be minimized. Originally Python code is like this. So W is 0.2 and 0.4, bias 0.1 after training. So W equal to 0.287 and 0.4179 and B equal to 0.117. The weight and the bias increase slightly, meaning neural adjust itself to better match target y equal to 1. What actually happened internally? Your neuron did this step forward pass. It combined the input, and this is the input 0.5 and 0.8 with the weight and bias to make prediction. Error calculation. It compared the prediction A with the true value y equal to 1 and found a loss 0.139. Back propagation. It computed how much each weight contributed to each error. Weight update learning. Adjust weight and bias slightly in the direction that reduce future error. If you repeat this update for multiple epochs, the loss will be keep decreasing, meaning neurons prediction will be get closer and closer to y equal to 1. So you will see something like this. Epoch 1 loss 0.1390, epoch 2 0.124 and epoch 3 0.156. Okay, example 2, visualizing back propagation single neural learning for multiple epochs. So here we put only one data. That's why it's give uh, decrease the loss, but only few amount. But here now we are going to use multiple epochs. So import numpy as np, input as a target, access the np dot array 0.58, input two features, y equal to 1 target, initialize parameter. So w equal to np dot array 0.2 and 0.4 weight, and y is equal to 0.1 and lr equal to 0.1. Activation and derivative. Diff sigmoid x equal to return x by 1 plus np dot x minus x. Diff sigmoid derivative x return x into 1 minus x. Training loop. Epoch equal to 50, number of training iteration. For epoch in a range, forward pass. Z equal to np dot xw plus p, a sigmoid z. Compute loss means square error. Loss is y minus 2 into 2. Same code whatever we use in the above. And back propagation, it's use the back propagation like this. Print progress every 5 epochs. If epoch is plus 1, percent 5 equal to 0 or epoch 0, print epoch plus 1 is to 0.2d. The final prediction after training, z final equal to np dot xw plus b, final a final equal to sigma z final, print final output. Let's see. here. We are going to epoch 50, and for each print progressive every 5 epochs. Let's see. Hmm. See this. Epoch 1 losses is 0.139019. After 5 epochs is printed 1. So the losses decreases 0.0118. After again 5 epochs, so 0.098 again decreases. Again, so see this, it decreases continuously and it's reached near to the 1. So final output is 0.8124. So train the same neurons for 50 step epochs. After every 5 epochs, it's print the loss, the current weight, and the bias here. The loss, current weight, and the bias. After the end, it prints final prediction output after training. The loss is shrinking each time learning is happening. The weight and the y slowly adjust it, make the neurons prediction closer to y equal to 1. The final prediction output 0.93 is much closer to the derivative value 1. So that they are trying to achieve the target, because target is give the output 1. A project title. Now we can use the same concept, the back propagation and optimization. We are going to create a real project. Project title. So Netflix movie recommendation using back propagation optimizer. Import NumPy as NP. Import tkinter. I am going to use tkinter to create an app where we can find a movie. It's predict the movie option for the viewer. So we are going to create a app for tkinter. Import ttk message box. Step on prepared sample data users movie. So these are the some name of the movies like Inception, Titanic, Avenger, Jokers, like this. And the users are Amit, Neha, Rahul, Priya, Sanjay. Rating is 0 equal to not rated. Rating is like this. There is 5 movie. 1, 2, 3, 4. 1, 2, 3, 4. There is 4 movie. 1, 2, 3, 4. And rating like 5, rating 3, like this. These are the ratings. People are giving the ratings like this. So train sample simple recommendation model. Num underscore user num movie equal to rating. So num features learning rate equal to 0.101, equal to 4000. So this way we can train the model so that according to the rating they give the advice. Okay. So this way we are going to create an app where we use advanced neural network so that they can recommend the movie. Let's go. Okay. So import the model. So import the code. Okay, so by using this code, we are going to develop a Netflix uh, app so that they can recommend a movie according to the rating of the movie. So this is the code, and we are going to use tkinter to create an app and NumPy as well as the neural network concept. Let's do it. Okay. See this. Netflix movie recommender. Select the user. See, these are the users. Let's select a minor. Get recommendation. So, Avenger predicted rating 4.08. Titanic predicting rating 2.24. Same way Rahul. Avenger predicting rating 5.92, like this. Inception. So this way they can recommend the movie according to the rating. Which is Avenger. Let's run again this code. This way they can uh, recommend the movie. Alright. The second concept is hyperparameter tuning in a neural network. So what is hyperparameter? They are the setting of training process, not learning automatically. Think of it like a this. Backpropagation equal to how you drive. Optimization equal to which route you take. And hyperparameter tuning is choosing the best car settings like gear ratio, fuel type, and tire pressure, etc. Example: learning rate eta, number of hidden layer, number of neurons per layer, batch size, number of the epochs, activation function, dropout rate, optimizer type. So tuning technique. So technique description tool is manual tuning, grid search, random search, Bayesian optimization, like this. So for manual tuning, trial and error, tool is simple but slow. Grid search, test all combination of hyperparameter. Grid search CV, Keras tuner. Random search is random combination, faster, efficient. Bayesian optimization is use probability model to find best params. Advice example Optuna and Hyperopt. So example of hyperparameter tuning using the Keras tuner. So import Keras tuner as a KT from TensorFlow. Import Keras from TensorFlow.keras. Import layers. Import NumPy as an NP. Dummy regression data. So x equal to np.random.red 500 comma 5. Then y equal to np.sum x equal to x minus 1 plus np random rand 500 into 0.1. This way we can create a code. Okay. So automatically find the best number of unit activation and learning rate by using this code. Let's try this. It will take some time because by using the TensorFlow, it will take some time. And once we run this code, this automatically find the best number of unit activation and the learning rate. See? TensorFlow takes some time. It will take some time. So here, hold on, it will take some time. Yes, processing. It's take longer time. The TensorFlow will take long time. This could take some time. See, it's processing. Yeah, still processing. Still processing. Wait. So basically, this is used. So they are setting of the training process, not learn it automatically. Think of it like this: backpropagation into how you drive, optimization, which is route you take, and hyperparameter using choose the best car setting like gear ratio, fuel, and time. This way it can perform. Still processing. And the third topic is implementing CNN for image classification. What is CNN? A convolutional neural network, CNN, specialized in image recognition and computer vision. So while it's processing, let's discuss the next topic. After that, we can check the result here. So instead of reading pixel by pixel, it detects features like edge, texture, shape using the filter and kernels. CNN architecture, convolution layers extract features, pooling layers reduce dimensions, fully connected layers make prediction. So this is a CNN handwritten digit recognition. Let's run this in the another page. Here it's coming now. See this. The layer type is and output shape and the prompts. So dense, non 128 and 776 and dense one, non 1 and 229. So total prompts is 897 and trainable prompts is 897. Non-trainable prompts is 0. Okay. Okay. So use this code for the third concept, that is CNN. It will use for CNN for handwritten digit recognition. Let's see. So when we run this code, you will see greater than 98% accuracy. CNN are create a visual pattern detection. So basically, it's used to specialize in image recognition and computation vision. Instead of reading pixel by pixel, it detects features like edge, texture, and shape using the filter kernels. Okay, it's processing. So it will take 5 epochs. Out of 5, this is the first. Wait a minute, it's processing. Meanwhile, we can check the next theory. After the third concept, we have to discuss about implementing RNN for sequential prediction. What is RNN? Recurrent neural network. Remember previous data. Ideal for time series, text or a sequential data. Unlike regular network, RNN have feedback loops, so past output influence future prediction. So type of RNN, type. Simple RNN, basic recurrent unit. LSTM, long short-term memory handle long-term dependency. GRU, gated return unit, simple version of LSTM. And the project is stock price sequence prediction using the LSTM. Let's check the old this code is working or not. Okay, so these are checking for the second epochs. Okay, now I think second is also over. It will take some more time. Done. Same way it will take 3 times. So this is the third one. Meanwhile, we can run this code in the another sheet. Okay. Let me do this here. Okay. So LSTM can capture ternate plus momentum unlike normal neural network. Summary of the module 6. The concept, backpropagation, error correction process, simple neural gradient update, optimization, efficient weight update method, ADAM and RMS Pro, hyperparameter tuning, search based model setting, Keras tuner demo, CNN, image classification, M, MNIST digit, RNN, sequential prediction, LSTM stock price. So out of 5, 1, 2, 3, 4 is running. Let's wait for some time. Wait for some time. Now it will take some more time. Okay. Now the fifth is starting. Okay, done. See, this is a image of 7 and it's predicted 7. So this is basically used for handwritten digit recognition. So this way, if we have a handwritten digit, our model can predict it. Let's try for this stock price sequence prediction using LSTM, that is using the RNN, recurrent neural network. So all the TensorFlow programs take lots of time to give the result. See this. This way they can predict the stock price, actual and predicted. So this way we can train our model to predict the stock price using the RNN. So thank you so much. This is the sixth model we have completed. That is advanced neural network concept.